Docker images, introduction to Docker. Quick. Let's talk about vocabulary in Docker. Very basic unit of Docker that you have is a Docker image. That is basically a template that we'll use to start or to create a running container. What does that mean? Think of the image as the application that you run, while the container is this application already running within the runtime environment. Which means the image is a standalone executable package of software that includes everything you need in order to run the application. And that's typically everything you need, but not more. So that's the minimal version of a container. And in order to build a Docker image, you'll need a Docker file. And incidentally, that's exactly the name of the file that you need. It's called Docker file. And you will see that in our environment, in our material. When a Docker image is run, it becomes a container. The container is an application packaging format, or actually I'm skeptical on that. It could be the image is a packaging format and then the container is the running environment, right? So there is some correction for this slide, at least as far as I understand it. And what we do in Docker is we're running a minimal application on top of the regular operating system kernel, mostly separated from each other. That is, if you run several containers apart from each other, they're all running on the same operating system kernel, but they can't see each other unless you say, I'd like them to see each other. And that's exactly what we will configure in this training. So you will run Liferay DXP in one container and Elasticsearch in a second container and the database in a third container. And then we have various other files. We have Docker volumes. What's that? Well, if a Docker image is a running application and a container is this image running in memory and on the CPU, this is immutable. So anything that the application wants to persist needs to be on a file system that is not separated from each other and will not go away once this image or once this container stops. But that's the default in a container world. We don't have any persistence in a container, which means we'll need to mount specific volumes that come from the host operating systems and they will stay persistent. That is, if you run a database and you want to keep that data, you'll need to allocate a volume for this database to store its data in. And that volume will then stay persistent, but that's independent of the actual container, naturally independent of the images. As it says here, volumes are recommended as a preferred way to persist data generated by containers. It just makes sense. You will see that when you install. Now, Liferay provides standard Docker images for Liferay DXP and for Liferay CE, by the way, as well. However, we do not use them because we want to teach you how to build an image from source, basically from a bundle. We're going to use Tomcat for this. And we're going to turn a Tomcat bundle zip file into a Docker image with a script, which is the Docker file, and that should demonstrate everything you need to know in order to know what's running within the Docker file. And that's the reason why we're not even looking at the regular Docker files that Liferay delivers. But here's the URL, here's where you can find them, hub.docker.com/u/Liferay. If you already use Docker, you will know the benefits why you use it. If you don't use Docker, here are some unique selling propositions for using Docker. First of all, it's portable. You can take an image and run it in any environment that you run Docker. That is, well, typically a Linux environment, but it also runs in Windows in its own kind of virtual machine, but let's say that it runs on every environment that runs Docker. So just shortened. Reduced overhead. If you compare Docker, a Docker container, with a virtual machine, then a virtual machine runs a full OS kernel on top of your host system, while Docker basically runs a process within your host operating system, and processes are designed to run within a kernel. So that's way less overhead than running a full operating system, booting that, and allocating all of the resources and keeping all of that overhead. So compare a full operating system with a process. Naturally, a process runs faster, takes less resources, and is just easier to maintain. You have shared data. You specifically say, this is the data that I'm interested in. This is a volume that I want to persist. Everything else is not persistent, so you're free to specify, this is what I want to persist, this is what I'm not interested in, this is temporary. And the volumes are stored outside of your image, outside of your container, which means if you replace your container with an updated version, you can still access the old volume because it's outside. So it means updates are simple because you have a separate notion of your code, of your container, and of your data in a volume. And the last one, version control. Changes can be easily tracked. Compare virtual machine image, what changed between two different versions of a virtual machine versus what changed between two versions of a Docker file. A Docker file is something that easily fits on a screen, maybe two, but it's an easy fit. You can look at a Docker file with a text editor. You can have a diff between two Docker files, so any update that you run in your Docker image will easily be version controlled compared with a full virtual machine where you don't have a diff. And then finally, we reveal that we will use an extra tool that's Docker Compose, kind of our poor man's orchestration on Docker. Docker Compose helps us to build the files with Docker Compose build and then the service name, to run the images as containers with Docker Compose up. -d it's running in the background as a daemon, and we have the shutdown command as well. Docker Compose down will shut down everything with PS. This is just a Docker command. We will display all of the active containers. We can restart a container, and we can attach to a container and read the logs. So those are just some very basic commands that we will need, and it makes sense to dog ear the monitor here when you watch the video to be able to come back. No, actually, we will have this in the exercises as well. But this is a list that actually makes sense to learn and to just use if you don't know it anyways. Now, next up is, this video is over, and I'll guide you, or I'll ask you to install Docker on your local operating system, which means we'll have that set up in written form in the next chapter. Watch out for the installation instructions to install Docker on Windows 10 or on Ubuntu or on Macos, and they're all laid out in the next chapter in written form. You will have to go through that without my guidance in video, but that should be easy. And after that, you'll have a couple of exercises in there so that you can run a very simple image, a Hello World image, and also an Nginx server that just provides you with a very basic web server, just to see Docker runs. If you get Nginx to run with a very simple image or a very simple container that you start, then you know, yes, Docker installation ran well.